Assalamu alaikum dear students, welcome back to my channel. In last lecture we talked about some burning questions and we also defined equivalent and equal sets. We defined subsets. In today's lecture we are going to start with some basic operations on sets, and these operations are vital in the study of group theory. These are very important, so let's start. So the first operation that we are going to talk about today is the union of two sets, right? Now the union of two sets A and B, denoted by A union B, is a set containing elements of both A and B with common elements of A and B mentioned only once as usual. Okay, so it contains elements of both sets and we write the common elements just once. So let's take an example of that. Let we have a set A which contains two elements A and E, and B contains E, I, O, U. Then their union is consisting of all elements of A and B, and if you look closely, this E is part of both the sets A and B, but when you take union you write it only once in the set. Why? Because repetition is not allowed in the sets we have talked about in our lecture number 1. Okay, the next very important operation that we are going to talk about is the intersection of two sets or more than two sets. Okay, so the intersection of two sets A and B, denoted by A intersection B, is a set containing common elements, if any, of A and B. Okay, so it just gives us the common elements of those two or more than two sets. Let us take an example. Here we have a set A which contains elements 1, 3, 5, and B is a singleton set containing only single element, that is 1. Then their intersection is 1. Why? Because 1 is the only element which is common between these two sets. Okay, and if I take one more example, we have a set which contains 3 elements 1, 3, 5. The other is Q which contains 2, 4, 6. So it's very clear, very obvious that there is no common elements between these two sets, so their intersection will be an empty set, right? And on the basis of this operation, this definition, we usually divide sets in two categories, and the first one is disjoint sets. Now if you take intersection of two sets A and B and you got an empty set, then those two sets A and B are called disjoint sets. And if their intersection is non-empty, meaning there is at least one common element between those two, then we call that sets to be overlapping sets. The next operation that can be performed between two sets is we can take their difference, or you can call the relative complement of those two sets. Okay, so what is this? The difference or a relative complement of two sets A and B, that is A minus B, or sometimes it is denoted by this, is a set containing those elements of A which are not in B. Okay, keep this in your mind. If you are taking A minus B, then you will take those elements of A which are not in B, and if you are talking about, let's say, B minus A, then you are going to take those elements of B which are not in A. Okay, keep this in your mind. So here we have an example. We have a set A which contains 5 elements 1, 2, 3, 4, 5, and B contains 1, 3, 5. So if you take A minus B, or you denote it by this, it's very clear that 2 and 4, these are the only two elements of A which are not part of B. So A minus B is 2, 4. It's a set containing two elements 2 and 4. Okay, and if you take B minus A, the same sets, using these two same sets, if we take B minus A, we are actually trying to find those elements of B which are not in A. As you can see that there is not even a single element of B which we could say that is not a part of A. So this is an empty set. Okay, the reason I have mentioned it here as well, because there does not exist an element of B which is not a part of A. Okay, alright ladies and gentlemen, before starting our talking about our next operation, we need to define a set, and that set is regarded as the universal set. Sometimes it is called universe or universe of discourse. All of these are its names. So it is a set containing all elements of the sets under discussion. In a problem, it is sometimes known as universe of discourse, or more simply as universe also. Let's say you are dealing with three sets, then the set which contains all elements of those three sets, that can be regarded as universal set for those for those three sets. Okay, keep this in your mind, it is highly relative term. Okay, if you change the sets under discussion, the universal set will change accordingly, right? So here is the operation that we are going to talk about after this definition, and this is the complement. The complement of a set A, denoted by A C or A prime, is defined as U minus A. If you are taking complement of a set, you are just taking difference of that set with the universal set. Okay, so this is difference or relative complement of A with U. So here we have an example. We have a set A and set U. Then you are going to take their difference. You already know that how to do that. Let's not waste over time here. So ladies and gentlemen, the next operation that we are going to talk about is an operation which is not very often studied, but it's quite important, and we can form groups using this operation as well. We will talk about that in later lectures. So what is symmetric difference? You people know that intersection gives us the common elements of two sets or more than two sets. Symmetric difference, on the other hand, gives us the uncommon elements of two or more sets. Okay, by the way, we usually apply this between two sets, so I am talking about two sets here only. So let A and B be two sets. Their symmetric difference, denoted by this, is defined as, now there are two means by which we can define it. Either the difference symmetric difference of A and B can be defined as A minus B union B minus A. If you talk about it, what will this give you? A minus B. A minus B will give you those elements of A which are not part of B, and B minus A will give you those elements of B which are not part of A. And if you take union of those elements, you will get those elements of A and B which are not common between them. Okay, one way to define symmetric difference is this. The other way around is, if you take symmetric difference of A and B, you just need to have their union minus their intersection. All of elements between contained in both A and B minus the common elements of A and B. Okay, this is also a way by which we can define symmetric difference. So let's take an example. So here we have a set A which contains three elements 1 2 3, B contains three elements 2 4 6, and we are interested in finding their symmetric difference. In other words, we are interested in finding their uncommon elements. So by the way, it's very clear from here, it's very simple example, so you can just pick the elements which are not common. 1 is not common between these two sets, 3 is not common between these two sets, 4 is also not common, and 6 is also not common, while 2 is common, so we are ignoring it. Okay.